6.2 Evaluating and Graphing Polynomial Functions. So a polynomial function. Basically what this is all saying is that if you have a constant term, that means that the degree is 0, and the standard form isn't really that important, but a constant polynomial function is a function that you probably know of. It's like me saying y equals 3, y equals 8, y equals 7. It's just a number. That is a constant polynomial function. Linear is what you talked about in pre-algebra and in algebra 1 mostly, where you just have an x. You just need to solve for that. So that's like saying x plus 3, for example. Really, that's just a linear equation, and the degree is 1 because the exponent is 1 right above this. We don't often say it, but it's like saying x to the first power. Quadratic, which we've most recently been hitting on now. Notice how there's a little 2 there for squared. Quadratic, the degree is 2. An example of that would be something like x squared plus x plus 3. A cubic, which is what we're going to start talking about more of. Notice how the highest exponent there is a 3 for cube, and there's an example for you. X plus 3, x to the third plus x squared plus x plus 3. And a quartic would be the degree of 4, and notice how the exponent there is 4, and this highest example is 4 as well. So polynomials. A polynomial is a function if f of x does not equal 0, and the exponents are whole numbers. That's very crucial, and that's very important for you to remember when we are discussing this, is that the exponent needs to be a whole number. Some other definitions for you as standard form. The standard form is the exponents that are in order from greatest to least. So when I say to you write something in standard form, what I'm really saying is take all the exponents. I want you to rearrange the order, but make it the biggest exponent first and work your way on down from there. The leading coefficient is what happens in standard form. First, you need to make sure that your equation is in standard form. Once your equation is in standard form, then the leading coefficient is the number out in front of the variable with the highest coefficient. And the degree is the biggest exponent, which we just talked about. The constant term is the number that's hanging out there all by itself, so a number that has absolutely no x with it whatsoever. So looking at example 1, we just want to see, hey, is this a polynomial or not? Well, the key here, what to figure out if it's a polynomial, is the exponents. Are both those exponents whole numbers? Yes, they are. And since they are, that means that that is a polynomial. When we look at this one, however, look at the exponents. This exponent is an x. Is that x a whole number? No, x could be anything. We have no idea what x is, which means that no, that is not a polynomial function. And if we check this one out, we notice that this right here is a negative. Negative 1 is not a whole number. Since it's negative, that means that it is not a function, or not a polynomial, because the exponent is negative 1. So we're going to talk about synthetic substitution now, which is some item that we're going to use throughout the rest of this chapter. But the best way to do this is for me to physically show you through examples on what we're going to do. So what I'm going to do now is I'm going to spend some time here showing you how to do a problem just like this. So with example 2, I'm giving you a polynomial function. 2x to the fourth minus 8x squared plus 5x minus 7. What I'm saying is take 3 and plug that in everywhere for x. That's what I'm telling you to do. Well, first of all, before you can use synthetic substitution, you need to rewrite this. Notice how I rewrote this in order the entire way down. And notice how it goes 4, then there is no 3, then 2, then 1, then no exponent or no variable. Well, I need to, before I can do synthetic substitution, I need to put that 0 in. And here's that 0. Here's that 0. So that's why I have 2x to the fourth. Since there is no x cubed, I have 0x cubed. It was negative 8x squared. It was 5x and negative 7. So I have that all written in there in order. And remember, if you're missing, you could be missing 5 different exponents. Let's say I gave you x to the 8th plus 7. You'd have to do x to the 8th plus 0x to the 7th plus 0x to the 6th plus 0x to the 5th, and so on. Anytime you're missing an exponent, you need to put a 0 in that spot. So once you have that in that spot, what you need to do is write down all of the coefficients. Okay, so all I did there was write down all the coefficients and draw these lines, and then on the outside, since it says x equals 3, I put a 3 right there on the outside. This is how simple synthetic substitution is. You drop down the 2 and to start, and all we do now is multiply. 3 times 2, and we get 6. So we add those together to get 6. So then I multiply again, 6 times 3, and I get 18. And once again, I add those together. Negative 8 plus 18 is 10. Then I multiply again. 10 times 3 is 30. And I add those together to get 35. 35 times 3 is 105. I add those together to get 98. So what we're saying here is, since that's your last number, 98 is your answer. What that means is when you plug in 3 into this problem, you get 98 out as your answer. End behavior polynomials we aren't going to look at. We'll get to that stuff probably in trig next year, but we're not really going to worry about that right now. We're going to worry just simply about graphing currently, and we are going to try to graph some of these items right here. So we want to graph this, and what we're going to do now is I'm going to teach you how to use your graphing calculator, because you've spent a lot of time now physically graphing these items yourself by substitution and plugging numbers in. So what I want you to do is I want you to go to y equals on your graphing calculator and clear that all out. And we're going to type in the x, and the x button is right beside alpha, so type in x. Whenever you want something greater than squared, like cubed for example, use a caret sign, and that caret sign is right under clear, and then 3 for cubed, so I just typed in x cubed. Then plus, then press x again, which is right beside the alpha, then squared, minus 4, press x again, minus 1, and when you go to graph, you see the graph. The graph kind of looks like this. It kind of goes up and around like that. Now there's an easy way here to figure out what all the points are on the graph. Very simple way. And here's what you do. You go to second and graph, and it shows this table to you. What it's saying is, it's giving you all the answers. It's telling you what y is at -2, and at -1, and at 0, and at 1. It's all there on that table for you. So the point is, the answer at -2, if you look at your table, is y equals 3. So when you plug that in, we get a 3 there. And at -1, instead of substitution and plugging everything in, when you get a -1, the answer is 3 as well. And at 0, when you plug in a 0, you end up getting -1. And we plot that point as well. That's 0, -1, and here's 0, -1. And at 1, -3 is next up on your calculator. So there's 1 and 1, 2, 3, down 3, put the point. And 2, 3 is your next answer. When you plug in a 2, you get 3, so over 2 and up 3. Now I know you're looking at that saying you have no idea how to graph that, but here's what I want you to do. Press the graph button again. I want you to connect this. I want you to connect those dots, but make it look like the graph that's on your paper. That's what I want you to do. Try your best to connect all those dots and make it look like the graph that's there. So you have those points, and there is the line with the graph with everything connected. When we come back, we will keep doing example 5, but we'll finish up 6.2 hopefully when we come back.